Today I'm going to talk about inverses, and we're going to start with a very familiar topic. So in the morning time when I wake up with bare feet, and then when I leave for work, I have feet with socks and shoes on, and I know in order to accomplish this, I have to, first put on socks, and then I have to put on shoes. So this is an ordered set of operations. Now when I get home, I want to undo this, so I have to undo this in the correct order, and we know that we're going to first take off our shoes, and then we're going to take off our socks. So when we undo it, we have to undo it in that reverse order. So if I look at a function, say f of x is equal to 2x minus 3, I really want to know what is its inverse. Like, how do I undo this function? Well, let's plug in a number and see what happens first and then what happens second, so then I can undo it in reverse order. So if I plug in, say, the number 5, this is going to be equal to 2 times 5 minus 3. So 2 times 5 is 10, minus 3 is 7. So f of 5 is equal to 7. So when I want to undo this, I need to undo this in the reversed order. So I notice I first multiplied and then I subtracted. So when I undo this in the reverse order, in order to get rid of that subtraction, which is the same thing as like your shoes, I'm going to have to take my input and I'm going to have to add 3 instead as opposed to subtract 3. Now the first thing I did was multiply by 2, so the last thing I have to do is divide by 2. Now if this indeed is the inverse, we know that f of 5 mapped to 7, so this thing should take 7 and map it back to 5. Let's check. What is f inverse of 7? Well, when I plug in 7, I know that I'm going to have to add first and then divide second. So that means f of 7 is equal to 5, verifying that if 5 maps to 7 through f, then 7 will map to 5 through its inverse. Thank you.